Hello everybody, I will start my today another coding session. So today I serve this question, Strobogrammatic number 2. So in this question, I'm giving an integer n, return all the Strobogrammatic numbers that are of length n. You may return the answer in any order. A Strobogrammatic number is a number that looks the same when rotated 180 degrees, looked at upside down. Okay. So let me clarify my understanding first. Okay, so as the interface, I'm given the integer n, and I will return all the Strobogrammatic numbers. And I can see from examples that each Strobogrammatic number should be string, so I should return the rest of string. Okay, good. So also I'd like to confirm about the n. So is n at least 1 or not? Yeah, n is at least 1. Those, I mean, maybe 0 is the Strobogrammatic number. So in the case of n is equal to 1, I should return something like 0 and maybe 1. This looks the same upside down. 2, no, 3, no, 4, 5. How about 5? Not sure. Maybe 5. And 6, this is not Strobogrammatic. 7, no. 8, yes. 9 is not, but this should be returned. I'm not sure of 5 and maybe 2. Let me think of this. 2 should look like if 2 is upside down, how does it look like? Two should be, yeah, Strobogrammatic, I think, and 5 2. No, actually no. 2 and 5 are not Strobogrammatic. Let me think why. Hmm? Why 5 is? Okay, so let me think. 5 should look like this. Yeah, and if I make it upside down, this side should come here. Let me check Strobogrammatic. What is it? Numbers that look the same when rotated 180 degrees looked at upside down. I'm quite confused. But maybe in the digital number, I think this should be, Strobogrammatic. But if on the kind of analog, this is not Strobogrammatic. So let's completely forget 2 and 5. This can never be included in the returned array, I think. But for 6 and 9, this can be, included. Yeah, I think this is ambiguous, but 6, 9 and 9, 6 should look strobogrammatic. Yeah, so this should be included in the result when n is equal to 2. Okay, good. I think I've understood this question. So let me think with an example more. And, yeah, with the case n is equal to 2. So I think if n is equal to 2, I think I have to do the kind of, brute force approach here. 11, 22. Completely forget, as I said, 2, 5, 6, 7, 8, 9, 10. So, okay. So I can say strobogrammatic itself this should be 0, 1, 2, 3, no, 8. And strobogrammatic pair, this should be 6, 9, and 9, 6. Yeah. And of course, 1, 1 can be strobogrammatic, but I don't include it here. When I say pair, the number itself, or I should say digit itself, is not strobogrammatic, but it can be, or I should say, this 6 should be the pair of 9, not 6 itself. That's why I say this should be 6, 9, 9, 6 pair. Or I should say, when I think of the pair, where I can say 0, 0 is pair, 1, 1 is pair, and 8, 8 is also pair. Maybe I can think of it in this way. So if I think of the pair of digit, it should be 6, 9, or 9, 6, 0, 0, or 1, 1, or 8, 8. But if I try to make it strobogrammatic itself, it should be 0, or 1, or 8. Okay, that being said, when n is equal to 1, the number itself has to be strobogrammatic. This should be 0, 1, 8. When n is 2, the pair should be strobogrammatic, so it should be these 5, pairs. It should be like this. And then when n is 3, this center x should be strobogrammatic itself, but and remaining surrounding pair should be strobogrammatic pair. So I can say this center should be 0 or 1 or 8. And this surrounding pair should be either of these. Yep. And n is equal to 4. I can expand this idea. This should be the pair, the strobogrammatic pair. And also this should be 2. Yep. So I think of every combination of these pairs. Okay, so according to, depending on if n is even or odd, maybe there should be, if n is odd, So if n is even, then I should think n divided by 2 pairs. Yeah. And if n is odd, I can say 1 strobogrammatic digit plus n divided by 2 strobogrammatic pairs. Yeah. Okay, that being said, now we're seeing how we can build the array. I think I can use 2, queues. So I think I can use the backtracking. So what I mean to say is I use first queue and second queue, and in the backtracking method, choose, I should say, and as the backtracking method argument, I will pass the index in the created number. So for example, if n is equal to 4, I should create number like this. So the index should be 0, 1, 2, 3. So, and I pass this start index and end index like 0, 3 or 1, 2 to this backtracking. And what I can do is append the first digit and append this one, that index number, to first queue, and also second queue. Then recursively call backtracking with that index plus 1 and index minus 1. Then in the base case is when start index is equal to end index or start index is larger than end index. So when start index is equal to end index, this means that I have 3 digits only and start and end is now here. So I choose the center number, then concatenate the first queue and second queue surrounding the chosen number, and I can create the string number. So I should append it to the return list. Yep. And also start index plus 1. No. In this case, this means that I've already traversed all of them. So it should be start index is here and index is here, like this. So in that case, I create the digit string and append to list and return. So these are the base cases. Okay. Now let me quickly talk about the complexity analysis. So for time complexity, so there should be n divided by 2 recursive function call or I should say backtracking method call. And for each, I have 5 options for pairs. Yeah. And as the base case, I have to concatenate and build the string, which will take n times, because first queue, second queue, and maybe center number, all the elements, number of all the elements should be exactly n. So I have to build the strings whose ranks is n, so which should take over n time. So with this, I can say this should be this time complexity. Okay. For space complexity, I need first queue, second queue, and return the array. But I don't include return the array in the space complexity analysis. So first queue, second queue, and recursion stack. So I can say first queue plus second queue takes up to n space complexity, because in total there should be up to n elements, including the center one. And recursion stack, as I said, it takes n divided by 2. So in total, it should be O of n. Okay. Oh, by the way, one thing I forgot to say is in line 57, I have to roll back first queue and last queue, second queue. Okay. That being said, I start the implementation. Okay, so I implement the find method. As I said, center number, center digit can be any of 0 and 8. So let me name it. Strobogrammatic. It should be, where is it? 0, 1, 8. Okay. And Strobogrammatic pairs should be here. I put them here. Oh. Okay. So now I put them in the constant, as a constant number. Good. So I can choose center digit from Strobogrammatic digit. So now I got the center digit. The digit should be this one. So now I get digit string. No. I would say number. I get the number here and I append it to read. Yeah, this is it. And return in C here. Okay. This is edge case number 1 and edge case number 2. This case, it should be only this. Yep, as I've seen in line 44 example. In this case, I don't need to, include center digit. What I have to do is just create digit list with first Q plus Q. Then I create number and append it to the fonts list. Okay, this is it. So now I've finished the base cases. So I go to line 55. So first and second digit, I see. So for here, I choose each pair from this. And D1 and D2 should be appended to first Q and second Q. By the way, first Q, every time I choose a new number, I append it to the, tail. For the second Q, every time I add a new number, that number should be appended to the head like this. Yeah, because I'm choosing numbers from outside to centerwards. Okay. So append to head, append to tail. Actually, the first Q can be stuck, but it doesn't matter. Okay. So now I've appended the first Q and second Q. And what I will do is call find method recursively. Then, after calling it, I roll back. Okay, this is it. So I think now I've finished the implementation. So let me quickly walk through my code. Let me sync with n is equal to 1. In this case, first Q is initiated with empty list, second Q2, then founds should be empty first, and I call the self.find 0 to n minus 1. So I call find 0, 0. And in line 89, this is true. Start index is equal to end index. So I will take a look at each Strobogrammatic digit, which should be 0, 1, 8. So center D should be 0 and then 1 and then 8. So when center digit is 0, digit array should be only, it should have only digit 0, which is center digit. So I create the number with a 0. So I append this 0 to founds list. Okay. Next, in line 90, I take a look at center digit 1 and I get number is equal to 1, which is appended to founds list. then 8 again, the same. 8 is appended to the found's list. Then I return. Okay. So return means I go back to line 86 and I return several founds, which is array 018. Okay, this is as expected. I passed this test case. So far I've covered the main method and line 89 to 94. I haven't covered line 95 to 106. So if I choose n is equal to 2, I can cover line 101 to 106, yes, but still I cannot cover 95 to 100. No, I can cover it because firstly, start and then begins from here and here. And then after choosing one number, end comes here and start comes here. So this is the case, base case, line 100. Okay. Wait, I think this is correct. Should be. Yeah, be like this. Right. Okay. So maybe I will cover n is equal to 2 case, but I don't cover all the possibilities. I will try to find the first number which is created. Okay, so when n is equal to 2, I go to the find method with firstly 0 and n minus 1 is 1. So 0, 1. And here, this corresponds to not line 105, not line 111. I go to line 217. And strobogrammatic pairs, the first one is 6, 9. So D1 is 6 string, and D2 is 9. Yes, so 6 is appended to first queue, 9 is appended to second queue, from this, direction, and from this direction. Yep. And I go to line 120 and call the find method with start index plus 1 and index minus 1, which is 1 and 0. Yep. And I go to line 105, and now start is larger than end. So I go to line 113, and in line 114, I create 6 and 9. The number should be 69. So bounds should append it with 6, 9. Okay, and I return. And I come back to line 122 and pop out this one from right. And in line 123, from second queue, I pop this left-hand side one, leftmost one. So now first queue and second queue are cleaned. Good. I could confirm that 6, 9 is inside of the list, which is definitely in the returned list. Okay. Maybe I should write one more test case with n is equal to 4, because in my n is equal to 2 test case, I couldn't completely test append left or right, pop left or right, that kind of direction. So maybe n is 4, n4 test case should be added. Yeah, but for the time saving purpose, I don't do that for now. And now I've covered all the lines, so I'm pretty confident in my code. I will execute. No, the problem is I have to make it queue. Maybe stack is fine, so I use stack. But yeah. But let me go with queue for now. Correction deck object has no attribute append wrapped. Okay, no underbar. And maybe here pop left. So this should be second queue. Okay. Can only concatenate deck, not list deck. I see. I can do deck plus deck plus deck, but not deck plus list plus deck. Okay. Wait, 0, 0 should not be included. I see. So trailing 0 is not accepted here. So this is the edge case. I had to think. So let me think how we can avoid it. So this is okay, but this is not okay. How we can distinguish them? So this 0 is used as the center number. But this 0 is used as the tail number. Wait. This doesn't work. But once I get 1, this works. So if I can allow 0 here, in this case here or here, completely depends on the previous choices. So maybe I can add another, flag here. Start can be 0. Yeah. I'm thinking if there is another way. Or maybe another approach is before appending the number to the found list, I check if it doesn't have any trailing zeros. I think either works. Let me go with the flag. So here I put around 0 start. Yep. Mm. So okay, what I have to check with this is when choosing the new number in line 128. So if not no 0 start, or I should say start not 0. Yeah, I think this is the most intuitive. So here, when I call this should be true. Start cannot be 0. And here in line 128, if D1, if start is not 0 and D1 is equal to 0, I should skip it. Otherwise, because wait, the only case I cannot take 0 is start index is equal to 0. If I can avoid 0 to be start index 0, I don't have to take care of it anymore. So I think I don't need this flag. So what I can do is just here. If start index is equal to 0 and D1 is equal to 0, continue. In this way, for the first number, I mean, the chosen number never becomes 0. So now I can avoid the trialing 0. Just in case, if n is equal to 1, I don't come here, but I choose the first number here in line 117, enter D. But in this case, 0 is acceptable because it doesn't become reading 0. No, actually reading 0, but it's a single digit. So it's okay. Good. Oh. Okay. Good. Accepted. Great. Okay, so let me quickly wrap up. So today I solved the question, Strobogrammatic number 2. So in this question, I'm giving an integer n and return all the Strobogrammatic numbers as the string list, whose number length is n. Number of digit is n. Okay. And for this question, I use the backtracking. So I use the two queues, first queue and second queue, and every time in the backtracking method, I choose the leftmost number and rightmost number and push them into each of first queue and second queue. Then I keep following the backtracking method recursively until start index and end index encounters, which means that I could choose all the digits for each expected digit slot. And when they encounter, I build the string number and append it to the return list. Okay. Only edge case I overlooked is that I cannot allow the reading 0 as long as n is not 1. So in line 128, I added this line to cover it. So if I'm choosing the start index 0, I have to skip digit 0. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.